Hello, everyone. Welcome to Chemistry with Professor John. All right. This is alcohol and phenol. Okay. This is the one of the most popular type of compound or class of compound or functional group that out there, presence in our everyday. All right. We just don't pay attention, but really alcohol, alcohol. Well, the term alcohol here doesn't mean drinking alcohol. It's all the compound with OH functional group. All right? OH functional group. So you have CH3OH, that's methanol. You have CH3CH2OH, that's ethanol. Now think about it. If you have a hydrocarbon with two carbons, CH3CH3, that would be called ethane or ethyl, right? You can also call ethyl alcohol. Very cool. Or, of course, this one, methyl. Methyl is for CH3 and alcohol is OH. So it's pretty cool, right? You got the official name and you also get the nickname or, common name. Just like Robert, versus Bob. All right. Let's take a look at, let me do something real quick here, guys. Okay. Okay. Let me open up again. Okay, here we go. Cool. All right, so we got CH3OH, that's methyl alcohol or methanol. We got CH3CH2OH, that's ethyl alcohol or ethanol. And of course, if you have three, 1, 2, 3, then we got to be specific, 1 propanol, right? 1 propanol, because alcohol is on carbon number 1. Because if you have that's 1, 2, 3, you got the alcohol on carbon number 2, so that's 2 propanol, and the nickname is isopropyl alcohol or isopropanol. Same thing. Okay, like I said, just like Robert versus Bob. Same person, same 2-propanol or isopropanol, same compound. Now, so alcohol has OH. Yes, let's take a look at the some of the physical and chemical properties, and then we'll look into more naming. Now, because it has OH, oxygen, and hydrogens, it does pretty good hydrogen bonding. Okay, so in general, if you compare alcohol with similar compound, it has higher boiling point. All right, so like methanol is such a small molecules, but it has a pretty good high boiling point, 65 degree, versus ether, right? this is ether. Look at the boiling point. Dimethyl ether. That even higher molar mass. But look at the boiling point, it's super low, okay? Due to the lack of hydrogen bonding. Now water is amazing. It's got 2 hydrogens, so that's a lot of hydrogen bonding. And you can see it reflects in the boiling point of 100 degrees Celsius for such a small molecules, okay? Now, so that's physical property that's very soluble in water, alcohol, because they can do hydrogen bonding together. A high boiling point, you know. Now, in terms of chemical property, if you look at the hydrogens of the alcohol, it actually has pretty good acidity, okay? If that hydrogen falls off, it becomes O minus. That's RO minus. Sorry about that. That's an alkoxide, all right? If that hydrogen falls off. Okay, so looking at pKa, water is about 15.7, and ethanol is in a similar range. And then you got isopropanol, and we got tubular alcohol, 18. Okay, that's a little bit, less acidic. And we got phenol. Surprise, it's 10. That's really stand out. That's smaller pKa mean more acidic. So, but that's got something to do with the conjugate base, because when phenol give up the hydrogen, it become phenoxide, which is O minus, and that's a very good conjugate base, stabilizing by resonances. So it's pretty stable, okay? And that's why the acid is pretty good. The hydrogen is very acidic, it's 10. Now, ethanol is 16, and then notice when you put in the halogens, it becomes more acidic, becomes smaller pKa, which is more acidic. And that's because halogen pulled electron towards the cell, making the hydrogen more positive, known as inductive effect. All right. Thiophenols are very acidic compared to alcohol, like 10, just fresh, by itself. No halogens. But that's because sulfur has lower electronegativity. It doesn't bond tightly to the hydrogens. So easier for hydrogen to be ionized or dissociated. Thiophenol even more acidic because of the benzene ring. Okay, that take care of the resonances. Okay, cool. The and as I mentioned earlier, that's inductive effect, inductive withdrawing effect of the halogens that make it the alcohol more acidic, making the hydrogens more positive, easier to take off as a hydrogen plus. That's why it's more acidic. All right, phenol is aromatic, the benzene ring with the OH. Okay, it's an aromatic alcohol. So when the hydrogens take off, the oxygen can do a lot of good resonances with the benzene ring, create a lot of resonances. And the more resonance is available, the more stable the conjugate base, more stable conjugate base mean more resonances, and that's mean is the more acidic the parent acid. The one we start out with. Okay, so Alcohol is really cool. When we take off the hydrogens, it become alkoxide, and it's super good base or a good nucleophile. And there's a number of ways we take off the hydrogens. Either we use a pure metal like potassium or sodium that donate the electron towards the hydrogens, turn that into hydrogen gas, and then the remaining will be the alkoxide. Okay, now we can also use sodium hydride, because hydride is H minus. Go ahead and wrap the hydrogen, become hydrogen gas, and then leaving us with alkoxide. When we get to phenol, which is benzene and alcohol, the pKa is so good, it's only 10. So that's acidic enough for us to use OH minus. Well, the way you recognize this, if you look at OH minus, remember come from water, and water pKa is 15.7. So let's say 16. So, and that's more basic than 10, okay? So, I mean, the OH minus is, that's larger than 10, so the OH minus is more basic. Then, therefore, it's capable of removing that hydrogen and make the phenoxide ion. Okay, the OH minus is more basic. That's why it can be done. Okay. Then phenoxide. All right. Now, maybe let's do a couple more on naming, and then we'll get into the reactions. How about that? Okay, so we'll back it off to some more naming right here, this empty space. Okay, so alcohol end with O, okay? So if you have like that, so obviously that's 1, 2, 3, 4, 5. So let's throw in some branches, you know. Notice that there's a bromine on the left, but we still have the number 1 on the right because that's alcohol. It's more important. It's a functional group compared to bromine. So we're going to call this a 5-bromo 3-methyl. Right there, 3-methyl. And this is a 1-pentanol. Okay, so that's an alcohol with branches. You know, if you have a pentanol like this, it's a cyclic, so you don't have to number it unless you got a branch. You know, if you have a branch, then alcohol is number 1 and the brand is number 2, but you just name the brand. Okay, 2-bromo cyclopentanol. Okay, you don't have to put 1 cyclopentanol. Okay, how about in the next video we'll get all the reactions done. Yep, thank you guys, and see you guys soon.